Eindhoven and camera angles and what we're looking at and related to vectors and kind of the brief start of axis, which we'll get into a little bit later. I'm going to take a step back, and we need to talk about actually viewing material now, actually viewing an EKG of some sort. Take everything I just said yesterday and today and apply that to EKG right now too. You got to practice this, okay? You need to have a systematic approach to every single EKG you ever look at. And you need to make it second nature. But in order to make it second nature, you have to have some sort of a systematic view that you look at them every single time the exact same way. So I'm going to present one way for you to do that, and I'm going to encourage you to use that way. And as we get more and more sophisticated rhythm strips that we look at, I'll add to this and adjust it slightly as we go to make the system a much larger system. But for the moment, if we take our 6-second strips, which is that packet that you have with 6-second strips, and you're about to get a thick book of a whole bunch more, when we look at that, there's an approach to every single one of those that you want to take. Okay? Sorry. The first approach in analyzing these things is to go through this step-by-step process of how you look at them. The very first thing you want to do is make sure or to pretend that everything is fine. Start with a normal person first. Even if the EKG is not normal, assume it's normal, right? You have to know what the baseline is before you can move on to identifying the bad stuff that's there. So, the very first thing that you do when you walk into an EKG, and I'm going to show all of this, the very first thing you're going to do is you're going to eliminate anything in that strip that looks bad. Anything that doesn't look normal. You're going to pretend it doesn't exist for a moment. You're going to pretend the bad stuff doesn't exist. I'm going to break every single one of these down in just a second. So pretend that whatever is bad in that rhythm, if there is anything bad in that rhythm, pretend it doesn't exist. Next, you're going to find out whether or not that rhythm has a normal regularity or an abnormal regularity to it. So you're going to find out what that rhythm is actually doing. In concert with its regularity, you're going to establish the rate. You're going to establish the rate from the EKG. Now, the rate from the EKG should match what their pulse rate is, but it doesn't always. Because remember that we've got two systems of the heart. We've got that electrical system, which is what EKG is looking at, and you have the mechanical system, which is the pushing of blood. And it's possible that the electrical system and the mechanical system are not working in concert like they're supposed to, or it could be that the mechanical system isn't translating into a pulse wave like it's supposed to. There's all kinds of different possibilities there. So we're establishing the rate based on the EKG. And this is telling us what the heart is being informed of, what the heart is being pressured to do based on that electrical activity. Then we need to look at the cardiac cycle itself. So start from the beginning. Look at the P waves. Do the P waves all look normal? Do they all look the same? What are the P waves? I'll come back to that in a minute. Measure your PR interval. Make sure it's within its normal parameters. Look at the QRS complex. Measure it. Identify some characteristics about the QRS complex. From that information, you will have enough information to give it a name, to actually give that rhythm strip an interpretation of some sort. And then from there, you can add back in whatever the bad stuff was and identify what that bad stuff is, whatever it happens to be. And the way that you say a rhythm, or the way that you write a rhythm, or the way you discuss a rhythm with somebody would be to say what the analysis is, then plug in the word with, and then list the crap. That's how you discuss it. So, for example, I have a accelerated junctional rhythm with ST elevation and 3 PVCs. I name the rhythm, I plug in the word with, and I identify the crap. if there is any. Make sense? Okay, so let's break all of that down a little bit here. So our first job when we're looking at a strip is to eliminate the crap. Now, I need to identify what crap is for a minute, right? Because I've been talking to you guys about not getting hung up on the exact look of a P wave or a QRS complex or a T wave, right? Because it depends on which camera you're taking it from, right? So when we're identifying the crap, what that means is that when you glance over this rhythm from a distance, you take a distant view of this rhythm, and you look, you'll see within that rhythm a whole bunch of stuff that looks the same and stuff that does not look the same, right? The stuff that all looks the same is what we're going to call the normal part of this particular rhythm, whatever it happens to be. The stuff that does not look the same is what we're going to call crap, and we're going to get rid of. So in this particular strip, what's our crap that we're trying to eliminate?
The PVCs.
Big down things.
The big down things. That's exactly right, and that's exactly what I would call them. These big down things need to be eliminated because it's different. It's not the same as everything else. Whether or not those are PVCs, whether or not those are aberrantly conducted PACs, whether or not those are aberrantly conducted PJCs, we don't know. We don't know what those are yet. But we don't care what they are because we don't even know what the rhythm is yet. So we get rid of those areas. We cover them up. And when you're first starting to do this, I would literally take a piece of paper and cover it up. So it's not even in your mind. You're not even thinking about it. Disregard it. You can do then one of two things. If you have a nice clean area of the strip like this, then you just cover up the beginning and cover up the end and just take that and just analyze these 4 beats. That's enough to analyze in this particular case. If it's not quite that clean and you need a little bit more strip, then keep the whole thing and take one of these clean ones and pretend that it's there. Superimpose it over the crap. Just pretend it's there for the moment. Okay? Then, once you've either created a new strip by superimposing a clean thing over the dirty thing, or you've eliminated it all together and you've just taken this little patch right here that you're going to deal with, that's all you're going to analyze. Because that's what the underlying rhythm is. That's what is happening with the heart as its baseline, and the crap is popping in on top of it. Questions on that? Are you clear on what I mean by eliminating the crap?
Does that include artifact?
Everything. Anything that doesn't look normal, eliminate. There are some times where the entire rhythm is crap, which tells you something all itself, which I'll get to later. But yes, artifact, anything, no matter what it is, pretend it's not there. Okay? All right. After we've gotten rid of that stuff, what's next? What should we be looking at next?
Regularity.
Okay, so we're going to look at the rhythm. We're going to get a general idea of the rhythm, and I will tell you that rhythm and rate have some crossover. So for example, you notice that the very first thing I've written in rhythm is something related to rate. Rhythm and rate have some crossover here, okay? But I need to identify the rhythm in order to truly get what I need to get for rate, which I'll talk about in a moment. So I'm going to, first of all, just take it in a very general sense. Is this a fast rhythm? Is this a slow rhythm? Or is this a middle of the road rhythm? Just to get an idea of the rate at which this is going. I haven't established the rate yet, but I just want a mental picture of slow, normal, fast. Okay? And the words that go along with that, which you already know. Then I want to identify if that rhythm is regular or irregular. Is this regular or irregular? And if it's irregular, what do I mean by that? Is it irregular with a pattern? Or is it irregular without a pattern? If it is irregular with a pattern, then we call it regularly irregular. Don't get caught up on the words. We call it regularly irregular because it's irregular, it's not coming in a regular fashion, but there is a regularity to it because it has a pattern to it of some sort. We'll discuss those patterns. Or is it irregularly irregular, which means initially it's irregular, and as I'm looking at it, I can't find any sort of pattern to it. So that breaks it down into three possibilities for my rhythm. Completely regular, a regular irregularity, or an irregular irregularity. Completely regular, completely normal, not normal, but with a pattern, not normal, and I can't find any sort of rhyme or reason to why it's abnormal. Good? Looking at all those. So when I'm looking at that rhythm, here's what I'm doing. I'm going to first take the strip, whatever the strip is. Okay? And I'm going to look at my P to P interval. What's my P to P interval?
And one P wave.
P wave to P wave. I'm going to take a look at my P to P interval. And I'm going to use a tool. What's my tool? Take a guess. Yes. I'm going to take my calipers. I'm going to take my calipers, and I'm going to put one caliper on one P wave, one caliper on the next P wave. If it's regular, what should I be able to do with my calipers?
Go to the next.
Yeah. I should be able to take that caliper, lift it up, set it on the next P to P interval, and it should be the same.
Why did you pick the P to P interval? Why didn't you pick the
Just for a moment. It's an excellent question, and it's going to be answered. So I'm going to check my P to P interval with my calipers, and if it's regular, I should not have to change my calipers on the P to P side. Does that make sense? Once I've established my P to P interval, and that my P to P interval is regular, then I want to look at my R to R interval. Right? What should my R to R interval be compared to my P to P?
The same.
So I should be able to take my calipers that I just used on the P to P interval, lift it up, and it should set right on top of my QRS complexes. And it should be the same. Does that make sense? Because we know when the atria fires, it fires in a regular pattern. The AV node does what to the signal? What's its primary job?
delay?
To delay. The delay should be exactly the same. Therefore, my R to R intervals should be exactly the same. So now I'm going to do the same thing. I'm going to lift my calipers from the P to P. I'm going to set them on my R to R, and I should be able to do the exact same thing all the way across. So now I've established two things. I've established whether or not the rhythm is regular, and I've established whether or not my P to Ps and my R to Rs match properly. It's given me a lot of information just off of checking that one thing. And it doesn't take long to do that. Good? If I can do that, and all my P to Ps match all the way through, and all my R to Rs match all the way through, and my P to Ps match my R to Rs, then we have a regular rhythm. We've just defined a regular rhythm. Questions on that?
Zach, so you wouldn't do T to T's?
Say that again.
T to T waves?
I'm not interested in T to T or any T wave information just yet because we're gonna add that down the road, specifically in our craft area. But what should my T to TBs be if my P to Ps and my R to Rs match? Right? Because my repolarization has to be the same. Because if my T's were off, then that means my repolarization is off. And if my repolarization is off, what does that mean about my next depolarization? It'll also be off. Right? Because if my T to T's are off, then my refractory periods are off from each other. If my refractory periods are off from each other, then the next depolarization will be ill-timed, differently timed. Right? Every single component of the cardiac cycle should be the same to the next one and to the next one, and to the next one, in any given moment in time for that patient. Unless they're in the middle of a change. Unless something is changing in them right at that moment in time. So from there, I've established whether or not they're regular, or I have to look and see, are they regularly irregular or irregularly irregular, if, when I did my caliper work, I found that it wasn't matching up. If I went from one R to R to the next, and it was off, then there's something wrong, or there's something not normal about that I have to then look at. So on a regular rhythm, I'm looking at the cadence of it. All the R to R's should match and be the same size. All the P to P's should match and be the same size. Good? Okay, so take a moment and think for a second. If something happens, pretend that all of these yellow lines that you see there are QRS complexes, and all of the blue dots are QRS complexes, but different. The blue ones are different somehow than the yellow ones, okay, in some fashion. If I have a situation where I have these QRS complexes that march out, and that's great, and then something happens. Maybe one's missing. Maybe this blue dot represents no QRS complex. Maybe it represents one of those big QRS complexes that we saw. I don't know, something's different right here. Something's not right here. But when I look over here, a little bit further down the strip, all of these match out also. Okay, that's weird. So then I look at this section, and I look at the next section that was normal, and I look at the next section that was normal, and I see a pattern that emerges. Oh, so I have 4 QRS complexes, and then a dropped one, and then 4 QRS complexes, and then a dropped one, and then 4 QRS complexes, and then dropped one. Okay, so I've got this 4-to-1 something or other that's going on. Okay, it's not regular, because there's something that's missing along the way that makes it irregular, but it does have a pattern. So we would call this regularly irregular. In this one we have 2 and something weird, 2 and something weird, 2 and a drop, 2 and a drop, 2 and a drop. Here's a 1-to-1 relationship, right? All of those would tell me that there is some sort of a regular pattern to it. Maybe I have a 5 and a drop, 4 and a drop, 3 and a drop. Oh, well that's not normal. But I go one step further and it's back to 5 and a drop, 4 and a drop, 3 and a drop. Oh, that's interesting. I get a little bit longer strip, and all of a sudden I see, oh, it's back to 5, 4, okay. So that also has a pattern to it.
So you're evaluating the crap in this instance only.
I'm not identifying the crap,
Okay.
but in this particular case, I'm allowing the crap to influence whether or not I'm seeing a pattern emerge in what I'm doing. And I will tell you that some of the crap we don't do that with at all, and some of it we do. Like the first strip that I told you to eliminate the crap with, we wouldn't say anything about that causing it to be irregular. But other funds we would. You'll come with that as we start talking about it.
Okay.
You see what I mean by the pattern that emerges though? So if I can identify a pattern, hey, how are you? We were discussing regularly irregular. What do you want to talk about?
Regularly irregular? Do I want to talk
No,
about
I just
it?
think if you want to step in, I could go take a vacation. No?
No, I have to make some.
Bye, Jenny.
Questions on that? You find a pattern in it, but it's not equal all the way through, but you identify the pattern in it, it's regularly irregular. Regularly irregular. That's different than one that has no pattern to it. So look only at this strip for right now. We're looking down at this strip, and you can't see a pattern to it. There's no pattern to it. You go, oh, wait a minute, Cory, because there's 2 yellows, a green, and a blue, and there's 2 yellows, and a green, and a blue. Fine, but it's interspersed by a yellow, blue, and a yellow, green. That's not a pattern. That's coincidence that those 2 came together, but the other ones are different. There's no pattern that emerges here. In this situation, as an example, maybe we have 3 different pacemaker sites happening in the atria. They're all getting control of their little area and they're all firing, right? Yes.
How long of a strip do you look at to determine whether it's a pattern or not a pattern?
It depends.
Okay.
It really does. Some of them you can pick up immediately on a 6-second strip. Some of them you're going, no, I need to have, 12 seconds or maybe even a full minute to really find out if there's a pattern to it.
Okay.
Right? And some of them based on our knowledge, we assume there's a pattern and then we confirm it with a longer strip. And you can sometimes just do that dynamically
Okay.
by watching it. And I'll give you some of those examples. You have the question? What is it?
On your pacemaker situation,
Yes.
2 of those are regular. The
Yeah.
third one is what's
Okay,
not.
so here's the deal. This one, where it says final strip, that's what I'm seeing on the monitor. That's what's coming off of my paper. But here's an example of how something like this could happen. So this pacemaker site, so here's my heart.
Is that lead 1?
No, these are not different leads. This is the only lead that you have. This is lead 1, lead 2, lead 3, AVL, AVR, AVF, V1, V2, V3, V4, V5, 6. It doesn't matter. This is the only thing that you're seeing on the EKG. This is what's happening in the heart that creates this that you see on the EKG. So imagine, just for a minute, here's what we have. There's my AV node. You all understand that the AV node is what is the thing that is going to initiate the QRS, yes? Right? It's not the start of the QRS, but electrically, after it leaves the AV node, that's where it's going to be set for the QRS, right? So the AV node has control over what's going to happen to the QRS. So our question in this particular case is, what's happening before the AV node? Okay? So let's say that I've got an SA node that is working. I have an SA node that's working, and the SA node is firing. But in addition to that, because of either a medication that this person took, or maybe there's an excitable part of the heart because of trauma or hypoxia or something else that created a disruption someplace, maybe I have this spot over here that also starts firing on its own. And maybe I have a third spot down here that starts firing on its own. So I've got 3 pacemaker sites in this particular example. I've got 3 pacemaker sites. The SA node fires and starts sending its signal. Yes? Through all of its gap junctions to all of its neighboring cells. This one starts firing and sending its gap junction through gap junctions to all of its neighboring cells. This one does the same thing. Good? And there are cells in between, right? This signal is traveling down to this cell. This signal is traveling up to this cell, right? And when we get to that cell, this cell right here has gap junctions to this cell and gap junctions to this cell. This cell fired and sent its electrons or its ions that way. This cell and sent its ions this way, right? That cell just gets overloaded with ions. The signal that went to this cell wants to send its ions what direction?
Either way.
Both. But can it go that way?
No.
No, because this cell's in its refractory period. Can it go this way?
Nope.
No, because that cell's in its refractory period. So for all intents and purposes, the signal dies right there.
The signal does go that way, but it's in its refractory period, so it doesn't matter.
Yeah, exactly. That cell can't refire. This cell can't refire. And the ions are just getting themselves, based on their concentration gradients, reset. Right?
So a layman's term way is they cancel out each other?
Yes. As this signal goes this way, it cancels out here. As this signal goes this way, and this one goes this way, it cancels out, right? And all of these signals are sending signals towards the AV node. Right?
That's like a normal life heart, or is that you're describing an irregular process?
I am describing a pathologic heart.
Okay.
Normal would not have this or this. Normal would just have this one that sets everything, the SA node. I'm talking about something abnormal is happening in the heart. And this is an example of why we see this final strip. So the SA node, let's say that the SA node is this blue one. Let's say that this one right here is this one. And this one right here is this one. So we've got A, B, and C. Okay? B is firing off a bit faster. Because of whatever reason, doesn't matter, it's firing off a bit faster than the other ones. C is, the slowest of them all. And the SA node, this A1 is just firing off somewhere in between. Okay? So because B is firing off faster, it sent its signal through gap junctions and got to the AV node before these ones did. Because it got to the AV node, these all represent what the AV node would potentially listen for. This is what the AV node actually sent. So this is a QRS complex. So what happened is B right here reached the AV node first, and so the AV node fired and sent a signal to the ventricles. We see a QRS complex. Got it? After the AV node depolarizes, what does it go into?
Okay.
It's got its refractory period, right? Now, during its refractory period, you note that this blue one fired a skosh before that green one, didn't it? But when that blue signal reached the AV node was still refractory, so it couldn't respond to that signal. Immediately after that, however, the green one fired, and the AV node was beyond its refractory period, so it could respond. So it paid attention to the green one. Now, right after it did that, that yellow one was sending its signal again, right? But what was the AV node?
Refractory.
It was refractory to it, so it couldn't respond to that signal. B was going so fast, though, that it sent a signal before blue or green ever sent another signal. So the AV node was reset and was able to listen to that signal. After it listened to that signal, blue had sent its signal, but it was refractory again, so it didn't pay attention to it. It couldn't respond to it. By that time, yellow had already sent another signal, and it could. It reached its refractory, went through its refractory by the time the green got set again, so it paid attention to the green, and now was refractory to the next yellow signal. Does that make sense? So the AV node is responding to whatever signals catch it at the time that it has completed its refractory period. And any signals that come while it's in its refractory period, it can't respond to because it's already depolarized. It hasn't repolarized yet. What ends up happening then is the AV node is responding to whichever signals get to it after it's past its absolute refractory period. And what ends up happening is you get an irregular rhythm underneath it because it's completely based on whenever the signal gets it and it happens to be past its refractory period.
Could
It's
you
a-
draw a rhythm that would look like that, please?
AFib, you bet.
It's the easiest one to draw. You don't have to be perfect.
Right? We'll come back to that in a minute, but in AFib you have all kinds of different electrical activity firing, and the AV node's going to listen to whatever it happens to get in contact with at the time it's through its refractory period.
So, the aggregate of all of those signals firing is what makes it irregular.
Correct.
In and,
And
of
that's
themselves,
what we see on the EKG.
yeah, but like in and of themselves, those pacemakers are not firing sporadically.
No. Those particular pacemakers are firing very regularly on their own.
But there are
When are you
several
gonna
different-
have? So essentially, that's just a hodgepodge mix of escape beats.
It is.
So when are you going to be able to differentiate between a not consistent firing of the pacemaker cell that's damaged to the pacemaker itself? Because right now you're describing there's nothing wrong with the pacemaker cells.
Correct. In this particular example, that is a correct statement. We have not discussed, we've not gotten past determining the regularity of the rhythm yet. We have to get a little further to identify exactly where it's coming from.
But we will be able to identify
Yep.
that.
No. Yes, you will be able to identify if this is a single pacemaker that is coming irregularly for some reason, or it's multiple pacemakers that are causing grief to the AV. You will be able to figure that out. This would be an example of what I just drew right there. You will be able to tell the difference shortly. Not yet, just because we haven't talked about it. But by the end of today, you will.
Unless we talk about dopamine again.
I would love to have another.
No tangents.
If you have time after this lecture, I'd love to hear your dopamine calculation lecture discussion.
Oh, I don't know that.
Okay,
First little dopamine club.
okay.
No one say dopamine.
So, if all of my P2Ps match all my RRs, and my calipers never have to change, I have a regular rhythm. If I have a rhythm that is irregular when I look at it, but when I caliper it out, I have patterns to it, then it's regularly irregular. And if I look at the rhythm and there's no pattern to it, it's all different, everything looks weird in terms of where the QRSs are landing, they're landing all over the place, then I have an irregular rhythm.
So or something like AFib would be,
Irregularly
Regularly.
irregular.
could you ever have irregular AFib?
No. It is the one rhythm, which we'll come to later, that is always irregularly irregular, and the only one that is always irregularly irregular.
Okay.
They've done.
Okay. We good on rhythm? What comes after rhythm?
Right.
Rate. So now we're looking at your rate. There's lots of different ways you can establish the rate. There's many different ways that you can look at and establish the rate. Okay? Some are memorizations, some are mathematical. It doesn't matter. They're all mathematical in the end, but there's many different ways that we can try to figure it out. You'll need to be able to calculate it yourself, and there's a few different ways. Okay? One way is what we call the triplicate method. The triplicate method is a mathematical way of doing it without you having to know the math. And you'll have to know the math in just a minute. But it's a mathematical way of doing it without you having to know the math to it. And that is just simply memorizing the numbers in the order that they come. So if I'm looking at my QRS complexes, if I have a QRS complex that falls exactly on one thick box line, and I'm looking at only the thick box lines right now, every thick box line, if my next QRS lands on the next thick box line, then I can just memorize what that rate would be. So if I have this one that falls on this thick box line, and my QRS complex, my next QRS complex comes 5 little blocks later, which is on the next big line, if that's where my QRS complex would have fallen, then my heart, and every QRS complex is falling that way, then my heart rate would be 300 per minute. If my QRS complex, my next QRS complex, this is my first one, I'm in a regular rhythm, so all the QRS complexes are coming regularly for the purposes of what we're talking about here. If my next QRS complex lands here, which is on the second big line, then it would be 150. If it's on the third big line, so here's my first one, here's my second one, then it would be 300, or then it would be 100. If it's on the fourth, then I'd be traveling at 75. You see how it works? If it were on this one, then it would be 60. If it's over here, 50, 43, 38, 33, 30, on the way down. So one way you can do it is just memorize 300, 100, 300, 150, 100, 75, 60, 50, 48, 33, 30,
Blah, blah, blah.
blah, 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 all the way down, like a phone number. You just memorize that. That's fine. You're going to know how it comes up with that too, the math, in just a minute. But that would be one way of doing it. And it's a fast way of doing it. It only works when you have a regular rhythm. As long as the QRSs are coming on a regular basis, then you can take any two and establish the rate. And you can either find one that falls on a big thick line, Or you can use your calipers, right? So this one doesn't fall in a thick line. So let's say my next one falls there. I can caliper it and then move my calipers to a big line. That's fine, right? That would be fine.
You said it only works on a regular rhythm. Does it work on a regular, irregular rhythm?
No, it works on a regular rhythm.
Regular, okay.
You have to make some mental adjustments if it's a regularly irregular or an irregularly irregular rhythm, which we'll discuss in just a minute. Questions on that method? Okay, that's one way to do it. Another one would be to do what we call the 6-second method. It is the least accurate of the methods, but it's fine to do as well. In the 6-second method, you count how many cardiac cycles are in 6 seconds. You know 6 seconds because our 6-second strips usually have hash marks at the top, right? And those hash marks usually come every 3 seconds on purpose. Or you'll have hash marks every second that are small and every 3rd second is larger. So you take a 6-second strip, count the number of cardiac cycles you have in that 6-second strip, and how many times does 6 go into 60?
10.
Right? So you just multiply by 10. It is the least accurate of the methods, but you can do that. You have to be a little bit careful. A lot of people will say just count the QRSs in that 6 second. I don't think that's adequate because that gets you off sometimes by a lot. So start on the hash mark, and wherever it falls on that cardiac cycle, maybe it falls just before the P wave, then count just before every P wave. However many you have just before every P wave in that strip. And you'll have to, you're never gonna, the second hash mark, the 6-second hash mark is never gonna be right in that exact spot. So you have to do a little guesstimating as to how far off that happens to be. So it's the least accurate of the methods, but it gives you a pretty fast way of going, okay, well, it's roughly this for right now. Okay. So that's fine. Or you can do the actual math. The triplicate method that I just talked about, 300, 150, 100, 75, 60, 50, right? As you're going down, 43, 38, 33, 30. That method is based off the math. So, how many big boxes are there in 1 second? How many, what's the time of a little box? 0.04.
5,
What's the
right?
time on a big box?
0.2.
0.2, so how many are in 1 second? 5. There's 5 boxes in 1 second, right? How many seconds are in a minute?
60.
60. So how many big boxes are there in a minute?
120.
300. 5 times 60, 5 per second, times 60 seconds. 5 times 6 is 30. You have the 0 on there. 300, right? So there's 300 big boxes in a second. So I'm just counting the number of big boxes between the QRSs. If I have 1 big box between every single QRS, then I'm taking 300, which is the total number of boxes per minute, and dividing by that number of boxes, 1. So my rate is what? 300. If I have 2 boxes between QRS complexes, then I'm taking my 300 boxes in my minute and dividing by 2, right? And I get what?
150.
150. If I take 3 boxes and I take 300 and divide by 3 boxes, then my rate is what?
100.
If I take 4 boxes, 300 divided by 4 is what?
75.
75. If I have 5 boxes, what is it?
60.
You see what they did? It's just the math. It's just straight out math. So you can memorize this, but if you forget, you can do the math. The other way you can do it, and the actual most accurate of all the ways, but not usually a very fast method, would be to do it off the little boxes. If there are if there are 300 big boxes per minute, and there are 5 little boxes per every big box, then we'd have how many little boxes in 1 minute? 1,500. So then I can just start counting my little boxes and divide them into 1,500, right? So if my QS complex was right there, I would have 5. 1, 2, 3, 4, 5. What is 1,500 divided by 5? 300. If it were here, I'd have 10. What's 1,500 divided by 10? If it was right here, I would have 15 boxes. What's 1,500 divided by 15? You see it's all math?
You can see that right up there.
So here we have 5, 10, 15, 20, 21, 22, 23. So we have 23. What's 1,500 divided by 23? Someone do the math. 1,500 divided by 23. 1,500 divided by 23. It's probably what, somewhere around 66, 67? What is it?
I think it's rounded like 67 here.
Great. Right?
Wait for it.
No one wants to be accurate.
65.22.
Great, so it's right around 65, 66. Great, perfect. Right?
When we're in the field and we know this method, can we say, oh, it's somewhere between 60 and 75, it looks about 67? Or
Yes.
should we do that?
No, that's perfectly okay because you'll be within a pretty close range, right? Right, you know that there's a 15 beats per minute change there. You're less than halfway, so you're less than 7 off, right? So 66, great. And it was awful darn close. I know, it's perfectly okay. Make sense on establishing rate? So there's a number of different ways you can do the rate. Pick the way that works the best for you and that your head works. There are some individuals that numbers and math is so stinking easy for them, they can count the little boxes and do the 1,500 divided by those little boxes in their head without any problem. Fine, I don't care. Do whatever makes the most sense for you to come up with the most accurate rate possible. Okay. So we established rhythm, we established the rate. All right, what do we look at after we look at rate?
P waves.
What comes after? All right, so now we're looking at the cardiac cycle itself. This is going to eventually answer Annalise's question that I said you're going to know by the end of today.
Yeah,
This is the start of that.
yeah, you're right.
Isn't that great?
Yeah.
So you got to look at the P waves now. I need to see what the P waves are doing. First thing, are there P waves? Are there P waves? To begin with. If there are P waves, are they all identical? If I have an irregular rhythm, but all the P waves are identical, you've got one pacemaker. If all the P waves look different, I've got multiple pacemakers. You already have your answer, and it's not even the end of the day yet.
Yeah, but I'm gonna overthink it in 30 seconds, so.
No
More
worries.
questions.
So we look at the P waves and make sure they're all identical. Mons, do you have a question or was that?
No.
Okay. Yeah, so you're looking at the P waves. Are they all identical all the way through? Great.
Sorry, by identical, do you mean at the consistent, like, a consistent time?
Nope, nope.
Or do you
You're
mean
looking at
morphology.
the shape of it. You're looking at the morphology. You're looking at the actual look of the P waves and do they all look the same? You've already established whether or not they come at a regular time or not. Now you want to know, do they all look the same? Which tells us if they're coming from the same spot or not. So we're looking at what they look like. We're also going to look, I realize that the PRI comes later, but remember we've got some crossover of things. So I want to know, do my PR intervals all look the same? I'm not establishing that number just yet, or in the future you'll be able to do a number of these things at once, but I'm not really caring about the value of the PR interval right now. I want to know that the PR interval is the same. The fastest way to find out that my PR interval is the same is to do what?
Calipers.
Yeah, set your calipers at the PR interval and yeah, they're all the same. No, they're not all the same. Okay, great. So I'm looking at my P waves if they're identical. I'm looking at my PR intervals if they're identical. If the P waves are not identical, there's a couple of possibilities. Either we've got more than one pacemaker firing, meaning we have two different spots that are creating the P wave, The atrial contractile cells listened to this pacemaker, and then they listened to that pacemaker. And then they listened to this pacemaker, and then they listened to that pacemaker. That's one possibility. Or the pacemaker is the same, but something else is happening that is being superimposed on top of that P wave somehow. Artifact, maybe. Maybe a different component of something that's happening in the heart at the same time. And you'll learn how to figure that out. We'll talk about how to identify that in a minute. And you'll have to figure that out. You'll have to identify if it's different pacemaker sites, or do I have the same pacemaker site, but every once in a while something's popping on top of that pacemaker. Because remember, the EKG is just a compilation of the average of everything that's happening.
You're talking PAC.
I'm not talking about,
One version.
that is one possibility. Not really a PAC, but the T wave from the previous one on top of a PAC, yes. Something's happening. Okay, then I'm going to take a look at my P to QRS ratio. Is there a P wave for all of the QRSs? Is there a P wave for all the QRSs? Are there any QRSs that don't have a P wave? If I have a different number of P waves than I have of QRSs, there's a block of some sort in there. There's something that prevented a QRS from coming along with a P